Okay, this is Thursday, August 30th assignment, and this is over isotopes. So for your quiz tomorrow, you need to know about isotopes, atomic numbers, protons, electrons, and neutrons. If we don't finish this assignment, it is homework. Okay, so model 1. This is going to be about isotopes. There's 3 different isotopes of each. So we have isotopes of hydrogen here, isotopes of carbon, isotopes of magnesium. You can write down the little notes I wrote at the top and at the bottom when we get there. So the number of protons is the same as the atomic number, and that's never going to change. So if we remember in our notes, whatever the element is here, okay, up here is going to be whatever number is here, mass, whatever number is here, atomic number. Okay, and that's all we need to know to learn about isotopes. So let's fill in these blanks, which are right here. So here's the symbol that they're showing us. The question says the number of protons. In this case, you can actually count in the picture, but as you go down to magnesium, you're not going to want to count all of that. On exams, you're not going to want to count every single little tiny plus sign. The more accurate way is to look at the symbol. Okay? So protons is the atomic number. We identified the bottom number as the atomic number. So the number of protons on all of them is what number? 1. So that's the answer for all of that. Okay? The next one says the number of neutrons. At the very bottom, I wrote this note, if you need to write it down. To find the number of neutrons, remember the acronym MAN. The mass number minus your atomic number will give you the neutrons. So what I'm going to be doing is pretty much this top number, the mass number minus the atomic number. The top number minus the bottom number. So if I'm looking at this isotope, it's 1 minus 1. How many neutrons? Yep, 0. And I look at this, the mass number minus the atomic number. What is it? 1. And then over here, it's 3 minus 1 gives me 2 neutrons. Oh, you don't have to put that symbol. Okay, so the front page is just getting you familiar with finding the number of protons and neutrons, and really the biggest thing is as long as you know this, you'll be able to get by. Okay, do we have any questions on this front page? Okay, let's flip it. Refer to model number 1. What subatomic particles do the following symbols represent? I think we can do that without going back. Okay, the only one we didn't see too much of, because there's only one right there, but that's going to be what's floating out in this, in this cloud. Okay, it's called an electron cloud, and there are electrons there. So if we flip the page, so it just wants us to identify what does the plus sign mean, what does the negative sign mean, and what does the clear circle, the empty circle mean. And you would just write your answer. So that symbol represented the electron, and then you guys can do the other 2. I think it's very clear. So when I'm doing this, I don't want to do the entire worksheet for you guys and you just copy. If you are getting the hang of things and you feel comfortable, please move forward. This is for anybody who just might need a little bit more help or is absent. Number 2, complete the table number 1 by counting the protons and neutrons in each atomic diagram. Divide the work. So it wants you to count protons and neutrons. I'm not going to make you count them. We already put how many protons and neutrons because we could figure it out mathematically. Okay, so this one's already done. because model 1 is this right here on the front. Okay, and it wants you to count the number of protons and neutrons. So for example, if you did want to see exactly what's going on, you would count the number of plus signs and the number of clear circles. That would be protons and neutrons. If you prefer that way, you can, but I recommend doing it mathematically. They're not always going to have the plus signs. Number 3, find the 3 elements shown in Model 1 on your periodic table. What whole number is shown in Model 1 for each element also found on the periodic table for the element? Hydrogen is 1. So they're asking you to compare it to your periodic table. Everyone should have a periodic table on your desk. If you don't, there'll always be some extra ones here underneath the vent hood for right now until you get your own. So it's asking you to look at your periodic table and what whole number for each element is found on the periodic table. Okay, so when we look at these, I'm just going to do it on the side, and it might be 1 and 1, right? That's what we're working with hydrogen. The whole number is on the periodic table. So the atomic number is a whole number on the periodic table. On the periodic table, is the mass number a whole number? If you look at your periodic table. No, because number 1, it's 1.008. So what it's asking for really is the atomic numbers of these elements. So carbon is going to be 6. Magnesium is going to be 12. B, you guys can do on your own. I've said it a bunch of times. The atomic number equals the blank and the blank. And what's going to be helpful on exams if you're still a little confused, APE. And you can refer back to your notes to get that. Refer to the isotope symbols in Model 1. Okay, where is the atomic number located in the symbol? So the atomic number, again, is in the bottom left-hand quarter. So it says, where is the atomic number located when it's in that isotope symbol form? Bottom left-hand corner. Okay, so now we're going to look at our periodic table. So number 4A, how many protons are in all chlorine atoms?
17.
Say it again?
17.
Yes. Okay. So it does say refer to your periodic table. You're going to have to look at this periodic table. You can either take this one home, you can always look it up on the internet, like periodic table, or you could take a picture of this one too. So chlorine's right here. The atomic number is 17, so that means it has 17 protons, 17 electrons. A student says, I think that some chlorines have 16 protons. Explain why they're not correct. So in your own words, protons do not change. Only neutrons change. Okay? Because the proton represents an atomic number. If the atomic number changes, you are now at a new element. Okay? If you change the atomic number, which is the protons, the number of protons, then you no longer have the same element. Okay? So protons will not change. Neutrons can. So I'm going to put if you change the number of protons, you change the atomic number. meaning it's a different element. Okay, let's check out number 5. Refer again to model number 1. In the isotope symbol of each atom, there's a superscripted raised number. This number is also the name of the atom. It is called the mass number. Okay, number 5 we're going to come back to when we start calculating average atomic mass. Okay, so number 5, I just wrote omit. You do not have to do number 5. Number 6, we did this similar to a warm-up. The whole first page was over counting protons, neutrons, and how you find the mass. I feel very confident that you can do number 6 on your own. I'm not going to do that one with you guys. I will not do number 7A. I'll do 7B. So how is the mass number, excuse me, expressed in the name? It's just written like. So when you actually write it out, the mass, this would be, and this one would be. The mass, which is always represented on the top, it's just written out like a dash. Number 8, write an isotope symbol for each of the atoms in question 6. There's only 2 atoms in question 6. So you could say any letter you want. This can be atom D, and this can be atom K. Okay, so they just want you to write it. I'll do atom 1 for you. I'll go ahead and do atom 1 for you. So on number 8, you just write it, then the isotope symbol. That's my atom, that's the element that I'm dealing with. The mass number needs to go on top, and the atomic number needs to go on bottom. So this is the one I labeled D, this is the one I labeled K. So for the atomic number, I know it's the number of protons. I can just count the plus signs, 1, 2, 3, 4, 5. And then you guys are going to find the mass number on your own. You can do number 9. Number 10 is a good exercise. It gives you some practice. I'll go ahead and do K for you, and then you guys will be responsible for these 2 columns. Okay, so again, I'll start here. The atomic number is, anyone? Yep. Okay. The mass number, yep. The number of protons. Correct. And the number of neutrons. You're going to take the mass number minus the atomic number, and that'll give you the number of neutrons. Does everybody feel comfortable doing those now after this much practice?